Hello, this is section 3.5, which is about implicit differentiation. So here, before I start, I will explain what is the difference between explicit differentiation and implicit differentiation. So in general, before we give the expression of the function f of x equal, and then we ask the derivative, okay, d of f. Implicit differentiation, the f or the y equal to f of x, is given by an equation, okay? So inside an equation, we have the y expression, which is not given explicitly, so that's why we call this implicit differentiation. Okay, look at these functions. So for example, what we have before, the explicit expression of the function y equal, or this form, and we want to we ask to find the derivative of this function. This is what we did so far before we start 3.5. The other way is to say that, okay, I have my variable x. This is x, the variable that we will use for the derivative. And we have the function y, which is y of x. We don't write y of x, but it is this function y here. So in the equation, this function, in fact. So y is not given explicitly. It is given by this equation. And we want to find the derivative of this function y in terms of x. So what we do, we take the derivative of the equation term by term, okay? So we'll see this in the next examples. Here, of course, we can find the expression of y in the previous equation, but it is not the purpose. The purpose is that we don't know the expression. Even we don't know the expression of y, we can find the derivative of y. So let's take this is another type of equations where we have y given implicitly. So I will go forward to the equation to make the derivative. Okay. So let's take this previous example, x squared plus y squared equal to 25, and we want to find d over dx, or sometimes we denote this by y prime. Okay, so and here we have to be carefully of the differentiation with respect to x, because y is a function of x, so we will use the chain rule inside when we compute the derivative. So you see here we have this term, the first one, plus this term equal to the third one. Making the derivative, since we have the equality between functions, so equality between derivative, and we have the derivative of the sum is equal to the sum of derivative. So that will give the following. So when we put the derivative on x squared, it will give 2x. So I will make like d over dx of the equation, okay? So it will give 2x for the first one, but the second one, since it is function of x powered by 2, so I will apply the chain rule. So it's 2y, don't forget, times y prime. If you remember, we have a formula like that, ux power n, and derivative of this is equal to n ux power n minus 1, but times u prime of x, okay? So that's why we have this y prime here, and equal now, derivative of constant 25, it's 0. So from this equation, this new equation, which contains y prime, I can find y prime, and it's easy actually to find. You will just move the 2x on the other side because it does not contain y prime, and you will have 2y, y prime equal to minus 2x, then divide by this coefficient of y prime. So y prime, it will be equal to minus 2x over minus 2y, simplify by minus 2, so it is equal to x over y. And that's the expression of y prime in terms of x and y. And that's enough to determine the value of y prime when we know the value of x and y at the point. Okay. So here, sorry, there is a plus 2 in this one. So it's minus x over y, sorry. This one is minus, of course, minus x over y. Okay, now I will go to the example number 1. This is already done in the previous example, but here we want to find as an application of the implicit differentiation, we want to find the equation of the tangent line to this graph. Okay, we know that y prime from the previous equation, that y prime is equal to minus x over y. At the given point, it will be equal to minus 3 over 4. So that means y prime at 3 is equal to minus 3 over 4. That's the slope, okay, of the tangent line. Then the equation of the tangent line is y minus the y of the point 4 equal to the slope, which is the derivative, minus 3 over 4, times x minus the 0.3. Okay, once you have this, just expand, multiply by 4, and you will get your equation here. Same thing if you have the normal from the slope, you will make just flip of the ratio, the slope, and add minus. That will give you the slope of the normal. And with the point, you will determine the y-intercept, which is b. Okay, look at these try and check examples. So I will start with the first one with implicit differentiation. So y cosine, that's the equation. Write the equation first, equal to x squared plus y squared. When I make the derivative with respect to x, and knowing that y is a function of x, so I will apply the rules of derivative here, the product rule. So it's a function y times another function. So the product rule will give y prime cosine x plus y derivative of cosine, which is minus sine, okay, equal to derivative of x squared is 2x, and derivative of y squared, chain rule, so it's plus 2y, y prime. And you see here that you have two terms with y prime. Try to make them together. So I will move this here, and something which is not depending on y prime, I will move it to the right. So in final, I will get y prime factor cosine x minus 2y, okay, equal to 2x, and here plus y sine x, because there is minus in this term. When we let it go to the right, it will be plus. Now divide by this quantity and you will get y prime. So y prime is equal to 2x plus y sine x divided by cosine x minus 2y. And this is the expression of the y prime using the implicit differentiation. Now I will get to go to example 2. B. So the derivative of this equation, all the time we have a product rule here. So 2x exponential y, derivative of 2x is 2, and it remains exponential y. Then plus 2x, derivative of exponential y, be careful here. So it's a chain rule. It will give the same thing times y prime. So EY times y prime out of the exponential term plus y prime EX plus y EX, because derivative of EX is its EX itself, equal to 0. Now, take the terms where you have y prime here together, and the other terms will go to the right. Okay, here and here. So y prime vector 2x EY plus EX equal to minus YEX minus 2EY. Finally, we divide by this quantity and you will get y prime. That's it. Okay. Now, in the second question, we want to find y secant. So we need first y prime. So we will differentiate the equation in terms of x. So it will give 4x cubed plus 4y cubed y prime. Don't forget this chain rule, equal to 0. So this will give me y prime. Okay. Now, if I want to get y secant, I have to differentiate this new equation star that I know. Okay, so again, d over dx of star will give me 12x squared plus, and here be careful of the rules of derivative. So for y cubed derivative, there is 12y squared y prime, and then plus 4y cubed y secant equal to 0. And here it appears the y secant. By the way, from star here, I can get y prime. So y prime, it will be equal to minus x cubed over y cubed. Okay, now in this new equation, I can find the y secant. So I will have here 4. There is 4 common factor. So 3x squared plus 3y squared y prime squared, but I can replace this by minus x cubed over y cubed plus y cubed y secant. All these equal to 0, so I can get rid of 4. And now I can, from here, I will get y secant equal, I will divide by y cubed over y cubed, and everything to the right, so it will be minus 3x squared minus 3y squared and y prime squared. Okay. The final step is to replace y prime by minus x cubed over y cubed, so it will make simpler a little bit more the computation. So here it will be equal to minus, there is minus common factor, so y cubed and 3x squared minus 3y squared times y prime squared, so it will be like 3x power 6 and over y power 4. Okay, So in final, I will get something like that. Let me make some room here. Okay. So it will be equal to over y cubed. There is minus 3 common factor. So I will put it outside the fraction. Okay. And then I will make the same denominator. So x squared times y fourth plus x6, but I will change the denominator here because I will take the common denominator in the numerator down, so it will be y7. Okay, just correctly this y. Okay, so that's the final answer for y6. Okay, now we can go to the next lecture, which is 3.6. Thank you so much.